with us. Welcome to an AMTNYS tradition. I think we can call it that. This is my 17th consecutive year of attending AMTNYS. It is my 17th consecutive year of bringing students to this conference. And that is some, yeah, that's a round of applause. My partner with me, Dr. Theodora Cox, has been doing this a decade. Is this our 11th?
This is our
11th year doing this. And we are so proud of this tradition because we've sent students, we say we, it's not just the two of us, it's all of us. It's the New York State community that has sent these teachers on to do wonderful things. And it always makes me feel very good to look around the room and see alums of AMTNYS returning off to wonderful and successful careers, not only in New York State, but all over the country, and that is important. So that's one tradition we're about to take part of. There is a second tradition that made its way into the room.
It's right there.
All right, so we want to invite everybody literally to the next room, right after the banquet. Next to my left, we will have the official 2016 dance-off. So get your team together. It can be as few as 2, it can be as many as a dozen. All we need to know is what song you're dancing to. If you make it to the finals, then it becomes a little more sophisticated. We sort of set the rules there, but you've got to be in it to win it. And it is, again, a possession or a prize that no money can buy. You must earn it. Speaking of earning it today, you're going to see 4 separate presentations that we hope you can steal. Absolute material that you can steal and use in your classroom, whether you've been teaching 1 year or 35 years.
Should we get that from the dance hall?
Both. All traditions, man. And that's what we want to do. Now, if you did not get a packet of information, that is not a problem. We've brought business cards.
That we'll be happy to share with you at the end of the meeting.
And we have everything here digitally as well.
Absolutely.
So for first introductions, let me turn it over to Dr. Teddy Cox.
Okay. Thank you, Dr. Howard. And I want to thank all of you. Many of you have been coming for years to our session, so it's a real pleasure for you to see the next generation of New York State and possibly teachers all over the world. Our first 2 presenters are Sarah and Samantha, and I'm going to let them step up so they can get set up here for the next few moments. What is neat about these 2 students, and actually we like working with all of our students, and we've gotten the opportunity to know them over the course of the past 4 or so years, is that sometimes we have neat connections or generational or family things going on. So for example, Sarah has the joy of having her parents attending today, and Sarah's originally from New Jersey, so her parents came from New Jersey and we still traveled farther than they did. But can you have a hand of applause for her parents who joined us? For us, it's very nice to work with Sarah, but we've also had the opportunity to work with her brother Joe years ago, and some of our students are surprised when I say that not only have we worked with Samantha for a number of years, but we've had the opportunity to work with Samantha's mom, and then people think we really age well, which we do, being around people half our age all the time. But in Samantha's case, her mom came back to teaching after many years of working on the family dairy farm and working as a librarian, so she joined our program just about the time that you were in high school or so. Okay. And Sam's mom, Brenda, graduated from our program. He's been teaching high school math in Virginia for several years now. So I'm going to turn it over to Sarah and Sam. They're going to tell us a little bit about history in the middle school curriculum.
Great. Thank you, Dr. Howard and Dr. Cox, for the wonderful introduction. As they stated, we're going to be talking about how we can incorporate more history of mathematics into the middle school curriculum. So to start off, we're going to do some fast facts. Now, what we like the audience to do is throw out some middle school topics, and we're going to tell you some really quick facts that you could use in your middle school classroom. So go ahead.
Deviation. Symbols. Okay, well I heard fractions. Sarah, do you know anything about fractions?
I do, actually. It's really interesting. So, fractions. The word fraction actually comes from the Latin word fractio, which means to break, and the ancient Egyptians would write their fractions only using unit fractions. So, if they had a fraction that was not a unit fraction, they would have to represent it with the sum of several unit fractions. Did you hear mathematical symbols? Because I think I also heard that.
Yeah. Okay, so addition and subtraction symbols have been around for thousands of years, but it wasn't until the 16th century when a lot of other symbols were used. And before then, they just had to write everything out, which could get really long and complex.
I think there was one more. There was also statistics one, which can be kind of hard to get some fast facts and statistics. Now, Carl Friedrich Gauss, he is a German mathematician, and he spent several of his professional years working on statistics. And he had such an influence in the German culture that if you look at their currency, his face is actually on their paper money. So, those are our fast facts for you guys.
Okay. So you're probably wondering, why would I include history in my math lesson? That's not in my curriculum. Well, there are a few reasons. First of all, it allows students to see math in a different light, and it also gives them a more humanistic aspect in the classroom.
It's also very easy to get information for your classrooms on history. For example, we have Google, and it's such a help. We also have this website called NACTutor, NACTutor History of Mathematics Archive, and in this archive you can get thousands of biographies on mathematicians. You can also get some topics such as algebra and geometry.
So today we are going to look at 4 specific modules or topics, and we are going to teach you a little bit about the history in them. So the first module we're looking at today is ratio and proportional relationships, which can be found in grade 6, module 1, and grade 7, module 1. So originally, ratios and proportions emerged in human activities, first practical, and then later more theoretical. The ideas of ratios would have been familiar to those in prehistorical societies, even in everyday life, such as one village being 2 times as large as the next village. And it wasn't until about 225 BC when the idea of ratios became more theoretical, when Euclid included about 18 definitions relating to ratios in his book Elements.
All right, so the next topic that we're going to talk about is integer exponents and the scientific notation, and this appears in 8th grade, module 1, and I really just want to talk about the foreshadowing of exponent notation, as well as where the square root sign came from. So if we go back to Kushar Abiyan Laden, he was alive from 971 to 1029 AD, and in his Arabic writing about Hindu numerals, he first represented his time period very well. He wrote his whole numbers using base 10, and he wrote his fractions sexagesimally. Now, for those who don't remember, sexagesimal numbers are simply numbers that are written in base 16. Now, in his writing, he said, let's take whole numbers and represent them as a degree. We'll then take 1/60th and say it's a minute. 1/60th squared is a second, 1/60th cubed is a third, and this continues. What he says next is, if we take a degree and multiply it by a degree, we're going to get a degree. If we take a degree multiplied by a fraction, we're going to get a fraction. And if we take a fraction times a fraction times a fraction times a fraction, we're still going to get a fraction. Now, back then, the exponent notation that they used was simply a little zero, or followed by then prime notation. Now, sure, this is a little bit easier to write, however, it can still get lengthy with prime notation. So, in his writing, he's saying there has to be a little bit of an easier way to write our exponent notations. So there's the foreshadowing of integer x for the exponent notation. Next, I want to talk about where the square root sign came from. Because some students might say, where did that square bracket thing come from? And you can first start off with the elaborate R, which was around the 15th century, and it was created by Richard Montanus. Now, the elaborate R, you simply write this elaborate R in front of a number, and that was how you take the square root of the number. This was used in several mathematical writings. But if I take it back a little bit more to the late 12th century, we can go back to the Arabic word shura. And shura, when translated from Arabic to English, means root, which makes sense if we're talking about the square root. So the first letter in shura to us is a J, but it's actually called a shim, and that's what's pictured on the slide. So they would write a shim over the number that they would want to take the square root of, and then they would take the square root of it. And if you look at shim, it sort of looks like our square root sign, just tilted a little bit differently. This was used by the Moroccan mathematician Abiyan al-Yazman.
So our next topic is units and conversions. If you didn't have a ruler, what kinds of things in this room might you use to measure this table?
Pennies.
Pennies?
Can we use body parts?
Yeah, you can use body
I
parts.
would use my finger, actually.
That's a good one. I mean, pennies and fingers might take a long time, but in fact, dating back to 3100 BC, Egyptians used different materials as units, such as a river length, aman, which is a fist, a dejaba, which is a finger, a durat, which is a hand, and a net, which is a rod of cord. And those units are all distant ancestors of the units that we use today, such as inches, centimeters, and meters. And units even go back to the biblical era, where they used units such as handbreadth etzbahs and cubits. For instance, Noah built his ark to be 300 cubits long, 50 cubits wide, and 30 cubits in height. And a cubit was just the measurement of a man's forearm, so from his elbow to the tip of his finger was a cubit. And so maybe a good activity for your students to do would be to have them measure the length of a wall or a chalkboard in the classroom. And we all know that all of our forearms are not the same size. And so chances are they aren't all going to get the same answer. So that just shows how units have evolved over the years and how exact they have become. Which brings us to the metric system, which came about in 1668 by Gabriel Moon.
So the last module we're going to talk about is in geometry, and we know that geometry plays a major role in elementary school, middle school, as well as high school. In 7th grade, since we're focusing on middle school, it first appears in Module 6, and it appears twice in 8th grade with similarity as well as congruence. Now, we all know that Euclid is the father of geometry, and we know that he worked with Euclidean geometry as well as Euclidean tools. However, he's not the only mathematician who worked on geometry. I mostly want to focus on Pythagoras and Pythagoreans. And now picture it as a picture of Pythagoras. And the Pythagoreans were given credit for finding irrational numbers through geometry. Now, those are some mathematical facts. I want to talk about some fun facts about Pythagoras, which I find funny and very interesting. However, some stories that we hear about Pythagoras, we're not really sure if they're true, but they're fun and they're good to have in the classroom. So first of all, Pythagoras had a god complex about himself. He believed that eating beans was sinful, which is hard since his followers, which actually were also cults, were vegetarians. So you're not allowed to eat beans. If you eat beans, that's just not good for you. There's a little joke that Pythagoras is walking along and he approaches a bean field. And there are soldiers there, and he says to the soldiers that I would rather die than step a toe into that bean field to cross it, which that's just crazy to me. So, also with Pythagoras, he believed that the universe was represented by numbers. He believed that men were represented by odd numbers and that females were represented by even numbers. Next, he believed that he could control the sea waves, control the winds, as well as predict earthquakes. Now, why don't we take out our smartphones real quick and find out what an S-bud is, see what the length of an S-bud is.
How do you spell it?
ETZBA.
That's
Or better yet, ask Siri.
Alright, we have one right here. What is it?
What do you have?
Nice one.
The S-bud, meaning finger, but sometimes rendered as finger breadth,
So it's like the width.
or even thumb breadth, was the smallest unit of length or distance in the ancient Hebrew metric system.
Cool. And see, that's just an example to show how easy that we can involve history and mathematics into our classroom, because that took less than 20 seconds to research something. So.
All right, so we want to thank you for listening to our presentation. Again, our topic was history and the mathematical curriculum. And if you have any further questions, please feel free to contact us at the emails below.
Thank you.
I don't know if we reminded you of the format. Just about every time we've got 4 sets of presenters today, about 10 minutes apiece, walking you through components of the curriculum. A shout out to Jake today, graduate student who had no idea that he'd also be our tech jock throughout the whole conference. Very first presentation we go to, it was Thursday at noon. Presenter didn't have the right cord for a laptop. Next thing you know, Jake is actually giving up his laptop for the very first presentation. He's here doing a lot of juggling today because we are going to spend a little time with must-have apps for math teachers. Today, Molly B. Roy joins us from the Rochester area. What high school did you go to in Rochester, Molly?
Webster Thomas.
One of the biggest schools. Webster was so big a few years back they split into Thomas and Strait.
Yes.
Molly did 2 years at Monroe Community College and has been with us ever since. She's joined by Katie Miller, who participated in a Sweet 16 at least, or was it an Elite 8? Tell us about an Elite. It's not every day that somebody gets to participate in an Elite 8. What was your Elite 8 in?
Lacrosse.
Lacrosse. So women's lacrosse as a senior this year for our lacrosse program, and that is a spring sport for us. So a big spring coming up for the Fredonia lacrosse team. Molly and Katie are tackling must-have apps for math teachers.
All right, thank you, Dr. Howard. As we said before, we're going to be introducing some must-have apps for math teachers. So to get started, you kind of want to get a feel for the room. So by show of hands, how many teachers started their careers without the smartboard?
Without?
Was not around yet.
Without any smartboard, okay.
Keep your hands up. What is the smartboard?
Okay, how many of you started your career without access to an Elmo or document camera?
It's going to be a long video. Started your career without the graphic calculator.
Without what?
The graphing calculator.
Without the graphing calculator.
All right, how about without the four-function graphing calculator? Or not graphing, four-function calculator. You guys are serious. I'm not trying to make you guys feel old, I promise. Our point is that technology is changing and evolving so quickly, and it's becoming such an integral part of education today, and we feel that the more you know, the better. So in the next 10 minutes or so, we're going to be presenting some apps that assist in a broad sense. We have an app for instructional delivery, grading, giving assignments, and also collaboration, not only between students and teachers, but also parents.
Okay, the first thing we're going to talk about is called Explain Everything. Explain Everything is an easy-to-use design, screencasting, and interactive whiteboard with real-time collaboration that allows you to annotate, record, animate, and collaborate and explore ideas, knowledge, and understanding. Explain Everything is similar to the more well-known app Notability. The difference is that Explain Everything is available on all major platforms. One of the features that is available on Explain Everything is that you can collaborate on the notes. In other words, teachers and students can take notes from their devices while the rest of the class can see from their own devices. Another feature is that you can flip your classroom on this application. Are we good? Okay. One of the features that we would like to show you is collaboration in the classroom. All right, so if I were in a classroom and I was just asking a question, if S of n denotes the n square number, what is the formula for S of n? And all the student would have to do is enter in the answer on their own device.
S of n equals n squared.
All right, and that is the
Use a
feature.
finger or a stylus?
It can be either or.
Stylus wasn't counted.
So what did you use?
I used my finger.
Okay.
Yeah, that also works. All right, and that's one of the features available on Explain Everything.
All right, so the next app we're going to be talking about is Google Classroom. Google Classroom is a learning platform that for schools that aims to simplify creating, distributing, and also grading assignments in a paperless way. So how many in the audience, as a teacher or a student, have trouble keeping track of things, organizing things, keeping things all in one place, whether it's grades, homework, assignments, any of that? All right, so me too. I understand, I really understand. Organization is not one of my strong suits. So why I find this app so useful is that the teacher can create a class period or a folder for every class period that you're in. Also within each file that you create, the app automatically creates a drive folder for each student in every assignment. Every assignment is placed on the assignment page and with class resources automatically placed into the student's drive folders. So this The app itself can essentially eliminate the excuse of, I didn't know what the homework was, I didn't know when it was due, or I didn't have the necessary materials. Because you did, because it was in your folder. So you're also able to check the completion of assignments, not only completion of assignments, but the process in which it happened. If you work collaboratively on Google Doc, you can check, the teacher can see the times, who, what student logged in what, and such like that. So on this assignment, you can see that out of all the students, all 6 haven't yet completed it. Ooh, sorry. All right, another feature is communication between parents, students, and teachers. The teacher can write comments right on the side of the student's work. The last feature I want to talk about is communication. We're going to skip the last feature, it wasn't too important.
All right, the next application we're going to talk about. The next application we're going to talk about is called Kahoot. Kahoot is a fun learning game that you can use that involves multiple choice questions. There are 3 different ways that you can use Kahoot. The first is you can quiz your students right on the app. The other way that you can use this is you can hold review games from this application. Another way that you can use this application is you can facilitate discussions or debates. And the third way that you can use this application is that you can survey your students. Suppose you want to have a statistics lab in your classroom for the day, and you want to know how many students in your class like a certain color. Well, Kahoot is a great application that you can use to find out how many students in the class like a certain color.
All right, so the last app we're going to talk about is Edpuzzle. So how many of you remember, either as a student or a teacher, if you wanted to watch a video clip, you'd love the big TV down the hallway, you'd have the VCR, you'd have to press play, fast forward, just to get, she remembers. Thank you. Thank you. She remembers, all remember. All right, so the beauty of Edpuzzle is that you can customize any video to your liking, and it's connected to YouTube, Khan Academy, National Geographic, TED Talks, Vimeo, and basically any video that you want to use educationally in your classroom, you can edit it to your liking. So I took the actual app Edpuzzle, and I edited a video that demonstrated the advantages of Edpuzzle.
Hello, AMTNYS attendees. This is Stella Katie speaking. I used Edpuzzle's voice-over ability to guide you through this quick video. The video was originally a few minutes long, but the editing in Edpuzzle allowed me to crop the clip and pause it like I am now. Now let's hear this teacher's take on the video superpowers of Edpuzzle.
Puzzle has truly given me superpowers. Here are the main benefits. Classroom management. I can assign a video in the classroom and walk around and monitor the students. I was shooting for omnipresence. Absenteeism. If a student is absent, they can access the lesson on my website 24/7. Consequently, I have students come back having mastered the lesson. Student accountability. If the student has missed the lesson due to behavior or other factors, the responsibility lies with them to go and view the lesson.
Let's pause it again real quick. Were you all following along? If you missed it, we have listed 3 benefits thus far: classroom management, absenteeism, and student accountability. Let's see what other benefits it offers.
Remediation. This is a wonderful tool for tutoring if you are working with more than one concept. Differentiation. Sometimes I play just the fundamental examples for students and let the more accelerated students watch all examples. Parent collaboration. When I have a student who is not achieving, I am able to call the parent or guardian and provide a resource that not only helps the student, but also enables the parent to watch, learn, and help if necessary.
Last interruption, I promise. Let's talk about the no-skip feature Edpuzzle offers. Students must watch the entirety of the video. They cannot skip through the parts they do not want to listen to, like possibly this part of the video in my voice. Let's continue.
I have found that the parents are grateful to have this resource, and it allows me to put the responsibility back on the student and parent. Lastly, it saves my voice.
All right, and the last thing I want to talk about for Edpuzzle is that you can quiz the students on their learning at any point during the video, beginning, middle, or end. So it's a good source to check for understanding and make sure they're actually grasping the concept or whatever you're teaching in that video.
So as much as we'd like to show you more apps and more information on the apps that we showed you, this is all we can show you in the allotted time. If you have any more questions for us, feel free to email us or stop us at some point during the conference. Thank you for listening.
Our next pair of presenters is typical in a lot of ways for me because one of the privileges of working with college students is that I not only get to have them in class and the students in one semester, but sometimes over the course of several years. And this is a pair of students that I've had as early as Calculus 1 a long, long time ago. Or at least that's the way it seems like. And next thing we know, we're planning for you to be student teaching next fall and moving on to bigger and better things. We have Kyle with us, and his mom was able to join us, so we can give her a round of applause. Michelle is from the New York City area, so they're both relatively local people. How far is home for you?
About a half hour or so.
Okay. Okay, keep rubbing it in after we drove 7 hours together.
That's what I do every time I come to Fredonia.
I know. And we appreciate every time you come back. At Fredonia, we have a unique learning environment because the math department has a layout that allows for students to have a centralized study area, which is called the fishbowl, because it has glass on the outside. You can kind of look in and see what's going on, and you hope there's a lot of math learning happening at any time. And Kyle and Michelle have been known to be a lot of times some of the first people in and last people out, like they've outlasted the janitor who leaves at midnight and so on. So I'm going to turn it over to you because they also share a love for Pokemon, and they'll tell you a lot more than I've ever known about that. So I'll turn it over to you.
Thank you for that wonderful introduction, Dr. Cox, and thank you all for coming to our presentation. We're going to be showing you why the perfect place for Pokemon is going to be inside your classroom. Now, a quick disclaimer, we do not endorse Pokemon, we're not getting paid to talk about them. And the other thing is, unlike our other classmates, we don't really have lessons for you to take, but hooks or anticipatory sets to use in your classroom to really engage your students and get them excited for your upcoming lesson. So let's get started.
So the first thing I want to ask everybody is, who has ever heard the term Pokemon? Now, who actually knows what Pokemon are? It's good to see so many Pokemon fans in here. Now, a quick discussion of what Pokemon are. Pokemon is a game that was created in 1996 by
Satoshi Tajiri.
who, when creating the game, was first thinking of bug catching in this case. But instead, he tried to be a little more creative and thought of what the actual term of Pokemon means nowadays is pocket monsters. So when you put pocket monsters and bug catching together, you get a game where you go around a whole entire region trying to catch as many Pokemon as possible. Now, some might see this as just a regular, ordinary video game. I know I've heard from my mother plenty of times, but in other terms, in other people's perspective, it's actually a way of life and a never-ending journey that keeps on coming up with brand new activities and adventures.
Okay, so we're going to be starting off with our first hook on combinations and permutations. So you see these typical problems where you have 5 shirts, 3 pairs of pants, 1 pair of shoes, and because you're a mathematician, all of your outfits match, and you want to figure out how many different outfits you can make. So let's take my little twist on it using Pokemon. Now, Pokemon have different types, and you can, basically, in the game, you want to optimize the amount of types you have on your team. So my question is, if I have 5 water-type Pokemon, 3 fire-type Pokemon, and 1 grass-type Pokemon, how many teams of 3 Pokemon can I make if I want 1 of each type on my team? Now, if you look into the center of your tables, you'll have a set of 5 Pokemon cards. Some of you have 2 for some of those bigger tables. If you look in the top right-hand corner of those Pokemon cards, you'll see a symbol that shows the type of Pokemon they are. Now, you can use these cards to form a tree diagram to figure out how many teams that you can make of 3 Pokemon. And I suggest you try it just for the heck of it. Unfortunately, though, because I'm a broke college student and I'm dealing with low funds, I couldn't get enough cards for the tree diagram to fully work, so you need to set it up as a pyramid, where each layer is a different type of Pokemon. And from there, you can kind of just count out each team. So Does anybody have that done by any chance? Or I'll leave you guys to do it for like a few minutes or seconds. Once you get the numbers, shout it out.
There's my parent, thank you. Yep.
I hear the number 6, and that sounds just about right. So you can see how fun this little activity is and how easy it is to incorporate it in the classroom. Another thing to note is that there are currently 721 Pokemon in existence. That's so much data that you can use to kind of manipulate and alter and adjust for your classrooms, which I think would be really fun.
So what I'm going to talk about right now is how we're going to incorporate percent increase and decrease. Now, if you look at the question right above here, you can see that it's a usual standardized question that you'd see on tests, where you're trying to find the price of a piece of clothing that has just been discounted. Now, we're going to take that and incorporate that into a Pokemon lesson that you might see. And to help out, my friend Pikachu here is trying to approximate pi, is going to help us out. So, in this case, Pokemon have their own individual stats. Now, some of them might have great attack power, some of them might have great defensive power, some of them might have some really good speed, accuracy, etc. In this case, we're going to have Pikachu at 100% accuracy. Now, if he's in a Pokemon battle with a Pokemon called Sandslash, and Sandslash decreases Pikachu's accuracy by 25%, then Pikachu increases his accuracy by another 25%. I'll ask you guys this. Is it still 100% accuracy at the end of that?
Now, how many of your students think it's 100%?
That is correct. The actual calculation is 92%, and we all know what that is, or how we do it. And this is a classic stump the chump problem that you can use into your classroom and use to incorporate with your students and you have them think out of the box most of the time and get them more motivated than ever to think about Pokemon in this case. I mean, what student wouldn't love to think about a Pokemon?
Okay, so the next thing we're going to be talking about is divided by fractions, specifically proper fractions. So if you look at my problem up above, you can see it's a basic problem. I've got fraction divided by fraction. What's it equal to? Now here's my take on it. In Pokemon, you have these things called battles. You basically pit two Pokemon against each other, like these two I've got up here. The little blue one's called Squirtle, the red one's called Charmander. So my problem is I have Squirtle attacking Charmander, and Charmander's health is decreased. For the record, his health is represented by that green bar, but Charmander's health is decreased by a fraction of his previous health. And then I tell you what the fraction of the total bar is that represents Charmander's health after being attacked. Now my question is, what would be Charmander's health before he got attacked? And this is a kind of tricky problem because it really does have students trying to read and observe what is being asked of them. But at the same time, I think it's really cool because it shows students that when you divide a fraction by another fraction, your answer is going to be greater than either of those two fractions. And I don't think a lot of students realize that. Also, if you flip in the packet, you'll see that we actually involve a coloring project to go along with this. So students actually get a color in the health bar to see it increasing. I think this is a lot of fun because it doesn't matter if you're in college or in kindergarten, you give a student a crayon, their day is immediately better.
So now we're going to talk about a little bit of system equations, or as I like to call a system of double battling equations. Now this is based off going what we've talked about already with Pokemon stats, percent increase, decrease, and also battling as well, and fractions. So in this case, we all know what a system equation looks like, where we have a regular problem at the top right here, represented by x and y. Now, to a student sometimes, that just looks like regular x and y. It probably doesn't mean anything. They probably don't even know what it actually means just yet. But if you incorporate Pokemon in this case and represent x and y as the battling powers of one or two Pokemon, then they can get really interested in here and start developing a love for x and y in this case and not freak out over something that's not a number. So in this case we have two Pokemon going against each other, against another two Pokemon, and you can calculate their attack percentage later on with solving for x and y.
Okay, so some of you may recognize this problem. It was on the August 2016, the Algebra 2 Common Core Recons exam. And it's a problem where students are given data about politics and they want to calculate a confidence interval. And I don't know about you guys, but I'm kind of done with politics for another 4 years.
Same.
Now, I've got a quick question for everyone in the room. Who here has heard of Pokemon Go? Please raise your hand. Okay, so everyone in the room. And this isn't really a big surprise because within its first week, it had made over $6 billion off of the app. So I'm going to show you some data I collected off of the game Pokemon Go. So if you look here, this is a chart that represents the weight of Pidgeys in our college campus. I went around and caught 13 Pidgeys and I graphed what their weights are. And I thought this would be a lot of fun. Basically, when you play Pokemon Go, it's unlike all the other Pokemon games in the sense where instead of you really focusing on battling and forming teams and everything we've just talked about, you're actually collecting Pokemon. And as you collect them, you collect data. You collect their heights, you collect their weights, you collect their types, you find out how many of them are in the area, etc., etc. So I think it would be really fun if you could have your students on a Friday afternoon just assign them for homework to go out and collect 5 Pidgey on Pokemon Go, and then take down their heights and weights and bring that data into the classroom on Monday. From there, you can have a full-on stats lab, and I give you a slight example on the last page of our packet, In this part, you can see I have students calculating mean, median, mode, standard deviation, is this a normal distribution, etc., etc. Overall, I think that this would be a ton of fun to interpret the data in class. I mean, you're having students play video games for homework. Who doesn't want to do that? So if you still aren't convinced on incorporating Pokemon into your classroom, let me give you a few more examples as to why you should. So most of us here know who Nell is, yes? For those of you who don't, she's a fabulous educational philosopher who really believes in incorporating happiness and fun into the classroom because in the end, we want our students to have fun before anything else. Most of you are parents, if not your older siblings, and you know that all you want for the younger generation is for them to really enjoy school and have fun and enjoy learning. Also, for those of you who were here last year, you saw Dan Meyer's keynote address, I would like to think. And he had told us that we should be making math problems more relatable to students. Pokemon is relatable. You've got people as old as me and Kyle playing it, and you've got kindergartners playing it for years probably. It's a fun game, and it's definitely a big part of pop culture.
And also, it's a great way to gather data. Just like we discussed about Pokemon Go, you can have students just go on the weekend and play video games and collect data that you can use for your classroom. So now, some people might look at this and say that it's actually not real-life data because it's not on a day-to-day basis that we go around seeing it, just like the clothing problem that we were looking at earlier. But really, it's just another thing that goes into a student's daily life. It's just maybe not in yours most of the case, but it's still. In this case, you can take that data still and have it as a great motivator. Like we said already, Pokemon Go has been a great motivator for students nowadays, and ever since it came out this past summer. And we have a new Pokemon game coming out in, I believe, a week or two? 2 weeks. In 2 weeks. Called Pokemon Sun and Moon. So in this case, you now have more than 100 plus Pokemon to gather data on.
In the end, thank you all for coming to our presentation. We hope you enjoyed it. If you want to find out more information, you can either contact us at the emails below or find us after this presentation's over. Thank you again.
Well, we come to our last presentation this late afternoon, and we have a trio. And they will be taking us around the world a little bit, so to speak. We start with Kyle, to my right. Kyle representing the Hamburg Bulldogs, is that what it was?
Yep.
On their football program, but as a Fredonia Blue Devil, he is a thrower. Is that how we refer to it?
Yep.
What precisely do you throw?
Weight, hammer, and discus.
Weight, hammer, and discus.
Yes.
And this is your senior year of throwing?
Yep. Last year.
On my left over here is Danielle. Danielle was a competitive swimmer through last year. About this time, you ended your career in the SUNYs. In what swimming event?
200 breaststroke.
And this
Means anything to
but it does. And this has been your first year without competitive swimming. How has that been?
It's weird, for sure, but I get to
I'm doing awesome things like this, so it's so exciting.
She gets to coach my kids.
And has moved from competitive swimming to coaching swimming.
Jill.
I want, Holly, you will be seeing, we hope, fingers crossed, in an upcoming article in the New York State Mathematics Teachers Journal. She's knee-deep in a statistics project that we hope to see published involving Lucky Charms. That's all we can give you right now. The title will be something magically delicious. We have more.
Are they magically?
Are they magically delicious? That's our little tease for the April edition of New York State Mathematics Teachers Journal. So these three will be taking us around the world.
Thank you, Dr. Howard, for that introduction.
We want to start off by asking, how many of you have heard the phrase that math is a universal language?
Okay, so now that we can all agree, or mostly agree, that we think math is a universal language, we've decided to take information and different things from three cultures and look at how to incorporate it in the math classroom.
So I've looked at the African culture, specifically what are called daitema, and I know that's an L on the slide, but it's actually pronounced as a D. And what daitema are is a geometric pattern that is created starting from a unit square, and then a series of reflections are performed, and then you end up with a really cool, intricate design. And there's actually a lot of math hidden within it. But they started more than 3 centuries ago, and they were created by the Lesotho women in the South African province of the Free State, Lesotho, and other neighboring regions. And typically you'll see them around religious celebrations or weddings, and you'll see them on a house like this. And as you can see, they generally contain 2 colors. Most traditionally, you'll see white and brown, but as you can see, they can be black and brown or black and white, just depending on the dye that's used. The dye that is used is created from natural materials that they have in their land. And to us, it just may look like a bunch of lines, but to them, they would interpret it as a story of maybe the field being plowed after a harvest, or how the animals migrate across the land. And I know what you're thinking, that looks really cool, but I just don't see the math in it. Well, you can give your students each a unit tile to start off with, and let's say we assume that this corner here is the origin, so we're working in the first quadrant. You can have them predict the equation of the line. So if I were to ask you what could a possible equation be for this line right here?
X squared.
This one.
X squared plus 1.
That's where it was 6.
Those are all really good. I wrote it as y equals x cubed plus 5. And then what about this line here?
Y equals x squared.
Yeah, good job. I wrote it as y equals x squared. And then what about this bottom line here?
Y equals 1/8 x squared.
Ooh, that's a good one. I had y equals 1/5 x quantity squared. And if you're working with linear relationships, you can do that as well. So, similar type of process, if we assumed that, if this corner was the origin, what would a possible equation of this line?
Y equals x.
Yep, I heard it in the back. I had y equals x. And then what about this line here?
2x.
Yeah, I had y equals 3x. And then what about the last line?
Y equals -2x.
Negative 2x plus
10.
Ooh, close. I had y equals negative 2x plus 10. So then, for the sake of
I could have
for the sake of the project, you would give your students a 3x3 grid or whatever grid you wanted. I stuck with 3x3 because after they kind of do it, it just gets tedious. So I think this is a good amount. And you can have them pick their pattern, and they can start in one corner. And then they can perform a series of reflections as we would have done if we used the traditional daikima. And we could perform a vertical reflection, and we get something like that. And notice every time you perform a reflection, the colors are negated. So regions that were brown are now white, and regions that are white are now brown. And then from there, they could do another reflection. Let's say we wanted to do a horizontal reflection. They could do that, and we would get something like this. And then if we put this all together, we would get a really cool art project, something like this. And unlike the real daikima, these are made to last. Traditional daikima, because they're made with either clay or dung plaster, they actually end up falling off the walls due to the sun bleaching them or just a heavy rain. So now you have a really cool project to display about your classroom,
So next we're going to be talking about a little bit about the Caribbean culture. And I found a software called Rhythm Wheel that will allow you to import their music and loop it around to create a song or different beats. Now originally the Caribbean islands were colonized by Spanish-speaking nations, and they brought slaves over to do the work for them. So the music that you hear now that you insinuate with Caribbean culture has the beats and rhythm of an African drum, along with Spanish guitars and string instruments. So this is what a screenshot of it looks like, but I feel like the best way to learn would be to actually go in and look at the software. So we have our resident beat maker here, Jake. So as you can see, right now the beat only has 1 on it, but the numbers right above it, you can change how many beats are on your wheel. So let's say 4. And then you can click and drag any of these sounds that you want in. And let's say you want to loop it around 3 times. So we know that 4 times 3 is 12. And this is a way that students, if you press play, students can actually hear that 4 times 3 is 12. Because in the end, it'll stop after the 12th beat. Another thing that you could do is maybe you want the heel noise to be your favorite outcome. And you could say that this wheel has 1 heel to 3 other unfavorable outcomes and make any sort of ratio like that. Also, if you go to the top left corner, you can add in more than 1 wheel. So let's say 2 wheels for now, and have that one have 6 beats. And you can click and drag whatever you want in. And you could ask your students, what's the smallest number of beats where both of these wheels are going to stop on the same note? We know that would be 12 because it's the lowest common multiple of these two. So you could say you're going to have to loop this wheel around twice to match the other wheel. I think we have next Kanye West to go. And you can do much more than that just by playing around with it for half an hour. It's a free software that we found online.
On the last page of your packet, there should be resources where you can find this website and other places where we found all of our project ideas.
Okay. So I decided to look at the Native American culture. So I focused on Native American beadlooms. These were originally created by Native American women, and they actually had 2 types to begin with. They had one that used embroidery, so they used straw or hay or whatever other material they could find. And the other one included beads, but originally they would use seeds. So after this evolved, they eventually got to beads, and they used real string, but so what you can look at with this is the symmetry. So originally I started off in the first quadrant, and I created my own design. They started off just using basic shapes such as squares, rectangles, triangles, and circles. And then from there, I reflected this over the x-axis to get what I got in the 4th quadrant. And similarly, I reflected it over the y-axis, and I got this part, which is in the 2nd quadrant. And could I have somebody come up and do a few squares of the last one? Any volunteers? Okay. And this was originally created by the Ojibwe tribe. And this this tribe is located in Canada, as well as North Dakota, Michigan, Minnesota, and Wisconsin. And another thing that it can look at is 4-fold symmetry. So if you look at it and you fold it along the y-axis, it's gonna be overlapping the same pattern. And similarly, if you fold it over the x-axis, you're gonna get the same pattern. So I thought this was a good way to have kids look at. Have kids look at the different symmetry. That's fine. That's good. You can, but That's why I chose the Native American theme.
We'd like to thank you all for coming to our presentation today. We have in our part of the packet, we have these 3 projects and then 3 more. And if you have any questions on those, you can contact us at all of these email addresses.
Thank you for coming.
Again, we got some time, a few minutes before things are officially over. I'd love to have you chat individually with some folks if you have specific questions, whether it be regarding technology or other components. If you did not receive a packet, Dr. Cox has cards, he has your email address, right?
Yeah.
And just send us a quick email. We will turn the packet literally back over to you digitally, so you'll have everything to steal and use in your own classroom. There are a few evaluation forms, I think, scattered about as well. But if you can just take a few moments and complete those, and we can have those to the staff as well. Grace, question?
I just want to thank you very much on behalf of AMTNYS. I love you guys coming. I think I've been here for the 11 times, trying to view how wonderful it is and how inspiring to a teacher who had to have the abacus in their calculus class, even though there was calculators, that was not allowed. So I'm just saying that I love how things have evolved. I'm happy for your enthusiasm, and I look forward to you all becoming great teachers.
Thank you very much.
We're going to stay in the morning, and then we're going to do swim. My husband keeps calling me.
That's great, thank you very much.
Your
son's having issues.
Yeah, probably. He's having meltdowns or whatnot. Today with you and that's wild. That's awesome.
Renee.
I heard of G Week. I heard of G Week.
I zoned out a little. Like, I've heard it so many times that it's